All right, we're going to continue on with our discussion of geometry topics here. A review of the circle work that was done in the math antics videos that you just recently watched, and then moving on to areas of composite figures. So it's actually covering three separate lessons in the textbook. But we've already kind of gone over this stuff in the math antics video. So circle vocabulary, right? The center of a circle, you need to know that the radius goes from the center to the outside. The diameter goes all the way across the circle through the center. The diameter is twice the radius. The radius is half of the diameter. And the distance around the circle is called the circumference, like the perimeter of a circle. And the formula for circumference is either pi times diameter or 2 times pi times the radius. 2 times the radius is the same as the diameter. And so that's why these two formulas basically are the same. The 2 pi r is more common because all of the other formulas that we have for circles will use radius. You'll see here with area uses radius. And then when we get to three-dimensional circle shapes like cylinders and cones and spheres, they all use radius in their formulas as well. So radius is typically the important measurement that you get for every circle. So to find the circumference of a circle, if you're given the radius, 2 times the radius times pi. So that's 2 times pi times 5.3. Now, one thing that the math antics video just mentioned briefly is the exact answer as compared to an approximate answer. So the exact answer has to use the pi symbol. And so the exact answer here would be doing all of the arithmetic except for multiplying by pi. The exact circumference of this circle would be 10.6 pi, but then typically you're going to put in 3.14 and in for pi. And so 10.6 times 3.14, round to the nearest tenth, which you always get rounding instructions in these types of problems. It's about 33.3 centimeters. Okay, it's like perimeter, so it is not square units, it is linear units. All right, so now this problem, sort of the opposite, they give you the circumference of the swimming pool and they want to find out what the diameter of the circle is. So you're going to use the same formula, C equals pi times diameter, okay? And you know C now, so you substitute in 40 for the circumference, you get equals pi times diameter. Well, in order to get diameter by itself, you'd have to divide by pi. So 40 divided by pi, about 3.14, comes out to about 12.7. So you can be given the answer and then have to calculate the radius or the diameter. If they asked you for the radius for this problem, that would be 1/2 of the diameter. So here is an additional problem. Ferris wheel has a circumference of 226 meters. What is the radius of the Ferris wheel? So since you're looking for radius, you can use the C equals 2 pi r formula. Substitute in the known values. C is 226. Then to get r by itself here, this is basically a one-step multiplication equation. Divide both sides by 2 pi, which is about 6.28. 226 divided by 6.28 is about 36. So the radius of the Ferris wheel is 36 meters. So you should be able to do this type of problem. All right, we're going to move now on to the area of a circle. So we talked about circumference. That's like the perimeter of a circle. The area, the number of squares that the circle takes up. Pi times radius squared is the formula. If they give you the radius, you do radius squared times pi. Again, You could have the exact answer here, which would be 81 pi. That's the exact answer. But typically, you're going to want the answer rounded to the 10th or the 11th, 10th or the 11th, the 10th or the 100th. So depending on what the instructions are. So rounding to the nearest 10th, about 254.5. It is also worth talking here that most calculators, most scientific calculators, have a pi button. And if you use the pi button instead of 3.14, you end up with a much more accurate answer. The pi button in the calculator runs the decimal places out to way more than the display of the calculator. Okay, but realize that if you compare that answer with one where they tell you to use 3.14 for pi, your answers are going to be a little bit different. The answer using the pi button will be bigger because the decimal, all those extra decimal places make your answer bigger. If you're given the diameter and you need to find the area, first you have to convert the diameter to radius because the area formula uses radius. So 15-foot diameter here means the radius is 7.5. So it's pi times 7.5 squared. Your exact answer, again, is this row right here. The exact answer is with the pi symbol. It is not before you round to the nearest 10th, right? The only way to have the exact answer is to have a pi symbol in there. If you use any number other than the pi symbol, you have rounded off. Semicircles, which are pretty common also to be, especially in the composite figures that we're going to look at in a minute. So to find the area of a semicircle, basically it's a circle, but times a half. So you can multiply by 0.5 or you can divide by 2. Either way, it's easier probably when you're setting up the formula to just do 1/2 pi r squared. 0.5 times pi r squared. Again, the exact answer is with the pi symbol, 450 pi. 30 squared is 900 times a half is 450. And if you use the calculator here, you get 1413.7. I think that the book here is, since it's not saying to use 3.14 for pi, it is using the pi button. Let's test that out here. So if we do 450 times 3.14, that answer is 1413 exactly. So these problems, since they don't tell you to use 3.14 for pi, they're assuming the pi button, and that's going to give you an answer of 1413 point, let's see here, 450 times pi, 1413.716694. Okay, so it's 1413.7.16694, and etc. with the pi button. Okay. And some calculators have pi buttons in different places if you can't find yours. If you do not have the pi button, then you just multiply by 3.14. So 450 times 3.14 equals 1413. So you see, depending on what you use for pi, you can end up with a little bit different answer. Most worksheets that you do that have, where you have to match the answer are going to tell you to use 3.14 for pi because they can't assume that everyone's calculators have a pi button. All right, so Now that we've reviewed the area of circles and semicircles, we can now look at combining these shapes together. So we're going to combine circles or semicircles together with other shapes that you learned last year. The parallelogram, the triangle, trapezoid, and a rectangle, of course, which isn't listed here. But the rectangle, area of a rectangle is, of course, length times width. So your most common area formula. So you have this on the notes page that was provided earlier, especially for the trapezoid formula or to remember the parallelogram formula. So a composite figure is composed of two or more shapes that you can find the area of. So a rectangle plus a semicircle, you just split the shape into two parts, find each shape, the area of each shape, and add them together. So an example in the book here is this arrow. Okay, so the arrow looks like a rectangle here and a triangle. So when you do these problems, you should identify the two shapes or three shapes or however many there are. Okay, identify the shapes and then what formula you are using for the area of each shape and calculate that. Then you need to figure out the dimensions that you need to use the formula. So for the rectangle, you need the length and width of the rectangle, which pretty straightforward here is 15 and 23. Okay, so that covers the rectangle. And then the triangle, you need the base and the height of the triangle because the formula for the area of a triangle is 1/2 base times height. Remember, the base and height of the triangle must be perpendicular. They must make a 90-degree angle. So this 8 inches is the height. And this distance all the way across here, you have to kind of figure out, right? It's 6 plus 6, these two end pieces, plus the 15 here. So that's where this 27 comes from, right? 6 plus 15 plus 6 is 27. So 1/2 times 27 times 8 is 108. The composite shape is all of these two pieces, the rectangle and the triangle, added together. So you add the two areas together, and your answer is 453 square inches, which normally we would write like this with an abbreviation, inches squared. Area is always in square units. All right, we'll do one more here. What is the area of this composite figure? So the first question, what are the two shapes involved here, or if there are two shapes? So there are two shapes here. See a semicircle and a triangle. So the semicircle and a triangle. The semicircle formula, 1/2 pi r squared, or 0.5 pi r squared. So we need the radius of the semicircle. So if you look at the picture here, it's 6 millimeters all the way across. So the radius is 3, which means my formula is 0.5 times 3 squared times pi. 4.5 pi, 0.5 times 9, is the exact answer. And this is about 14.13 using 3.14 for pi. If I use the pi button, I also get 14.13. Now, the instructions have you round to the nearest tenth. You don't want to do that until you're at the very final answer. So you should always carry at least one extra digit in your rounding in the intermediate steps of problems like this where you have multiple things going on. All right, so the triangle then, 1/2 base times height is the formula for the area of a triangle. The base is 6, the height is 16, and so the triangle area is 48. The total composite area, add these two things together, 48 plus 14.1, rounded to the 10th, and your answer is about 62.1 square millimeters. 62.1 square millimeters. Make sure you have square units for all your area calculations. All right, so composite areas are very common in multi-step problems. They have this one in the book. A ceiling tile covers 3 square feet. Okay, so you're buying ceiling tiles. Each one is 3 square feet. And your ceiling is shaped like this octagon here. So how many ceiling tiles do you need to purchase to fill up this ceiling? Well, we can try to figure out what shapes the ceiling can be broken into that we can figure out the areas of. It is a rectangle and 2 trapezoids. And so they go through the 2 trapezoids are congruent. They will have the same, I guess you can assume, they have the same dimensions, height of 5, base 1 is 10, base 2 is 18. So you substitute into the formula, base 1 plus base 2 times the height, times a half. That comes out to 70. There are 2 trapezoids, so that's 140 square feet for the 2 trapezoids, plus the 20 by 18 rectangle. Add them together, 360 plus 140 is 500 square feet, the composite area of the entire ceiling. And if each ceiling tile is 3 square feet, how many 3 square foot tiles does it take to fill 500? You do division there, and it's about 167. So this is just an example of a multi-step problem using composite area. We'll do one last one here. So this L-shaped counter is going to be replaced by a new countertop that costs $52 a square foot. It's not unreasonable there for a granite countertop. All right, so how much is it going to cost? How many square feet are there in this L-shaped countertop? What is the final cost going to be? Well, we can split this into 2 rectangles. The easier 2 rectangles are these 2. The smaller one, 3 by 2, or 6 square feet. The larger one, 3 times 10, or 30 square feet. Easy arithmetic here. The total square footage of the countertop then is 36 square feet. And since each square foot costs $52, we multiply to get the total cost. The countertop here is going to cost $1,872. $1,872. That is not too far off from what these things cost. I can tell you from experience. All right, so we've covered here a review of the circumference and area of circles that we covered, that you did in the previous video. We also talked about semicircles, and then we talked about composite areas, which puts together different shapes and adds them together. In the next lesson, or on Friday, we will talk about some other more complicated compound figures where shapes can be taken away and things like that. But for now, that's good, and we'll give a few practice problems on circles and composite areas, and then we will look at some additional composite areas in the next lesson.